are the founder and CEO of Oslo-based Vind. Tell me, what does your company do?
Yes, so we are a software company. So we create a cloud-based software for designing new offshore wind sites. So if you are a wind developer and you are looking for new sites around the world to design offshore wind sites, or if you already have found a site and you want to place the turbine layouts and cabling layouts, etc., we provide the software that makes this very easy to do and gives you decision support on the way. So these are some screenshots from our software, and very happy to do live demonstrations as well.
How is your software, how is your technology different from other softwares in the market? What's different about yours?
Yes, so there are a lot of different softwares out there that specialize on one specific domain. So for example, GIS softwares or wind resource softwares, cabling softwares. And what's different from us is that we try to combine all of these different areas together into one software so that the whole project team can work together in one interface and see and evaluate the same project. So that's what's different from what's out there in the market.
And in what markets are you operating already?
Yes, so our software is global by nature, which means that we have bathymetry data, wind data, metocean data all over the world. But most of our customers are based in Europe, but they're using the product around the world for projects.
You're using, for your system, you're using artificial intelligence. That's obviously a controversial topic. How do you think can we control the beast we have created?
Yes, so I disagree a bit in the sense that it should be called a beast, to be honest. But I do agree that there are some risks to this technology. So I think sensible regulation is, of course, a very, very important thing and an obvious answer. And I know that both the EU and the US are working heavily on this, which is great and important. But I also think that we shouldn't be afraid to take advantage of the opportunities that this technology enables us to do. So that's what we've done in Vind AI. We are leveraging this technology to make it faster, more efficient, to develop new wind farms, and also to enable you to take into account the social aspects and environmental aspects of building out a farm.
All right, and inside your company, do you have any checks and balances for that? How are you going about that?
So internally, we have engineers that are very, very experienced in this domain. So we're always thinking about all the different ethical aspects of evolving our systems further.
All right, thank you very much, Helen.
Thank you.
We have Joshua Singer, I believe.
Sorry.
Hi, Joshua.
Hello. Can you see me?
Yes, we can see you. We can hear you. This is amazing. Thank you for joining us.
Okay, hi.
So you are connected with us from Boston, as I said, and you're offshore wind ports lead at port and maritime consultancy Moffat and Nichol. Your company developed a software called FlexTerm that creates a digital twin of ports. Why are you doing this? Why is this useful?
Yeah, so what the software is, it's a dynamic simulation tool. Like you say, it's a digital twin tool. And we design, we're a ports and maritime consultancy. We design ports all over the world, and we have a division that designs offshore wind ports. And in that work, we realized that there was a need to be able to visualize the projects and kind of analyze the performance of the projects prior to project's execution, right? So what the tool does is it creates a very low-risk environment where you could test different scenarios of the movement of WTG components and foundations through a port and create efficiencies in the system. So like the way we kind of look at it is it's very easy to visualize an offshore wind port on day one, when you have like a CAD drawing and a nice, arrangement of the components on the terminal, but it's very hard to visualize on day 140 if the system is performing well. So the model allows, the analysis of the performance of the terminal. Yeah, I'm not seeing video, but basically what I can tell you is like what you're seeing in the video is if the video is playing, what you're seeing in the video is the model running, right? And you can see in the upper left, it's basically a visualization of the project. So this is the Port of Esbjerg that we modeled in Denmark. And that is the 3 marshalling terminals that we've modeled there. You're also seeing some additional storage and then some factories that are producing components. You're seeing the delivery vessels come into the terminal with the different components from all over Europe, and then you're also seeing the install vessel, which is the gray vessel that's picking up the components from the terminal, right? So it's all to scale. The model knows how much space is needed for each component based on the gigawatts of the nameplate on the nacelle, and all of the stuff that's happening on the terminal is to the rates that it's happening are real-time rates. And then you're seeing in the bottom left, there is a schedule, project schedule. So what we do is we track the project schedule, which is quite often important to the end users, right? So we can tell if all the project is happening within one install season. We track the milestones of the project. In the upper right, you see the berth utilization being tracked for one of the berths, right? So one of the primary functions of the model is to make sure that the berths don't get overloaded. The delivery vessels coming in and out from different places. Quite often there's berth sharing at delivery berths, and this helps track and make sure that the berths are not overloaded. Below that, you see the graphs for the uplands inventory, right? So it's important that we track the uplands inventory. It's basically making sure that we don't zero out in any component, so that the components that the install vessel is not waiting for a component, and the price is ticking up on that very quickly. And then it's also making sure that we don't overload the terminal. So like, there's a delicate balance. You want to keep a certain amount of sets on the ground as inventory, so you have resiliency in the supply chain, but you also have to make sure that the input and the output are somewhat balancing themselves, so that, like I said, we don't zero out or overload the terminal.
Right, and I understand you've been deploying this software at container ports for about 10 years. But 2 years ago, you started off in the offshore wind energy sector. How far advanced are you in that sector? How many projects, how many ports are you working with?
Yep, so it's been a busy 2 years. We have successfully modeled, like the model that you're seeing now, it's the Port of Esbjerg, which is the biggest offshore wind port in the world. And then we've also recently finished a project at New Jersey Wind Port, which is the biggest offshore wind port in the US that's currently being built, and we did the design on that. We are also working with various ports in the UK and in the US to continue the modeling efforts. As an example, for Esbjerg, we were able to triple the throughput capacity from 1.5 gigawatts to 4.5 gigawatts using the model, iterating different examples of layouts and rates and processes over one installation season.
You have been deploying it at offshore bottom fixed offshore wind projects, or at ports that are providing pieces for these projects, and you will soon also enter the floating offshore wind energy market. How is it different? How will your model be different when you go into that segment of the market?
Yep, so like you say, right now we are running fixed bottom marshalling, so it can handle all the processes for WTG components and foundations through a port. Once you move to floating, it gets a lot more complex because we are doing 2 activities at the port. We are doing the foundation, either the assembly, the manufacturing assembly, and then a WTG marshalling terminal, ideally right next door, potentially 2 different ports. So all of the processes are more complex, and there's more processes. We were having to hook up produce the foundation and then hook it up at the port, integrate the components onto the foundation at the port. So we are working on the floating module that is due to be ready in September. And like the big difference, I think, will be like the fixed bottom one is kind of confirming rules of thumb of the industry, like how it works. The floating will help work out the problems that everybody knows is in front of them and is trying to solve, like wet storage, serial production lines, and the interaction of the foundation and the components at the port.
All right, thank you very much, Josh.
Okay.
for taking the time. Sorry for the technical problems. So it was great to have you anyway. Thank you.
No problem.
Thank you.
Thank you.
Thank you, Helen. Thank you for listening.
Thank you.